irrational numbers that are expressed with a square root. Give, for instance, you have the square root of 3, square root of x, and so on. Give, for instance, look at it so you can see it. Square root of 10, and so on. So these are surds. We'll be looking at how to add, subtract, multiply, and divide surds. Let's go into addition and subtraction. For us to add and subtract, we are looking at combining two surds in such a way that their coefficients are the only ones adding. And it's important to note that if the surds are not similar, they cannot be combined. Give, for instance, if we have root 2 plus 5 root 2. These two surds, that is the square root of 2 and the square root of 2 here, they are similar. So the coefficients we add. For this number, the coefficient is what? 1. So this is the same thing as saying 1 root 2 plus 5 root 2. So this will give us 6. 1 plus 5 root 2. For addition and subtraction. If, for example, we have root 3 plus 4 root 2, these two surds cannot be combined because the surds are not similar, so they can't be combined. Let's look at multiplication of surds. Now, in the case of multiplication, the combination of the two surds is regardless of the likeness of the surds. If, for instance, if you have the same root 2, but this time multiplying root 3, so they are not like surds, but they can be combined. So this will give us root 2 times 3, which is the same thing as root 6. If we have, for example, again, 2 root 2 multiplied by 3 root 5. Here, the numbers or the coefficients will multiply themselves, like this 2 times 3, then the roots, root 2 times root 5. So this will give us 6, then multiplied by, this time this will be root 10, which is the same thing as 6 root 10. Let's look at division of surds. So if we have A all over root B, is the same thing as saying root A all over B. And this is vice versa. Now there are times when we solve or simplify in surds that we have roots as the denominators. And in surds, it is not allowed. So we do what we call rationalization. This leads us to rationalization of surds. Now, give for instance, if we have 2 all over root 2, and we want to rationalize this, we have a root 2 as a denominator. It's not allowed. So to rationalize this, we use the denominator, the figure there, root 2, to multiply both the numerator and the denominator. So this will give us 2 all over root 2 times root 2 all over root 2. So this multiplied by this will give us 2 root 2. And this multiplied by this will give us root 4, which is equal to 2. Because the square root of 4 is 2. This can cancel this will cancel it out, and we have root 2 as the answer. If, for instance, we have, let's see another one, let's say 3 root 2 all over root 3, and want to rationalize. This will give us 3 root 2 all over root 3 multiplied by the denominator, multiplying the numerator and the denominator. So that will be root 3 times root 3. When we multiply, 3 multiply 1 is the same thing as 3. Root 2 multiplied by root 3 will give us root 6. Then this multiplied by this, we already know it will give us root 9, which will give us 3. So this will cancel this and we have root 6. So now, in some cases, we have an expression as the denominator. And for us to rationalize, we introduce what we call the conjugate of that denominator. If, for instance, we have 2 all over 1 minus root 3. Now, to get the conjugate of this denominator, which is 1 minus root 3, we take this same thing, but we change the sign. That is the operation there. So the conjugate will now be equal to what? 1 plus root 3. Let's move over to this side. So we have 1 minus root 3. We are trying to rationalize this. The conjugate we have seen is 1 plus root 3. So this will be multiplied by 1 plus root 3 all over 1 plus root 3. To multiply this, remember that the number will multiply each element here. So 2 multiplied by this will give us 2. 2 multiplied by root 3 will give us plus 2 root 3. Now for the denominator, which is 1 minus root 3 bracket 1 plus root 3. It is important to remember that in algebra we have what we call the difference of two squares. That is, when we have x raised to power 2 minus y raised to power 2 is the same thing as x plus y bracket x minus y. So the same thing goes here. You can see here that you have 1 minus root 3, and at the other bracket you have 1 plus root 3. So we can introduce the difference of two squares easily by saying this equals to 2 plus root 2 root 3 all over 1 raised to power 2 minus, taking the difference of two squares, root 3 squared. Let's solve it here. This will give us 2 plus 2 root 3 all over 1 raised to power 2 is what? 1 minus root 3 raised to power 2 will give us what? Root 9. Root 9 is equals to 3. So this will give us 2 plus 2 root 3 bracket 1 minus 3 is what? Minus 2. So this, we can see that we have some common factors here, so we can bring out 2 again. So this is 1 plus root 3 all over minus 2. This will cancel this out. So we have the minus coming up, minus 1 plus root 3 all bracket, and we open the bracket. This will give us minus 1 minus root 3. So this is how we rationalize Surds. Now let's look at some questions from our JAMB past question. Question number 1 from 2011. Rationalize 2 minus root 5 all over 3 minus root 5. We said that to rationalize, we multiply the conjugate of the denominator. Now, the conjugate of the denominator will be 3 plus root 5 all over 3 plus root 5. That is changing this sign. So the numerator will be 2 minus root 5 plus root 5 all over 3 minus root 5, 3 plus root 5. Now we multiply. This multiply each element. This multiplied by this will give us 6. 2 multiplied by root 5 will give us plus 2 root 5. Minus 5 multiplied by 3 will give us minus 3 root 5. minus 5 multiplied by plus 5 will give us minus root 25 all over. So using our difference of two squares, we have 3 squared minus root 5 squared. So we simplify this minus this, that is 2 root 5 minus 3 root 5 will give us minus 1 root 5. But we don't write it 1. We have 6 here. Root 25 is minus 5. Square root of 25. Then all over, this will give us 9 minus the square root will be cancelled by the power, which will give us 5. Then 6 minus 5 will give us 1 minus root 5. 9 minus 5 will give us 4. So this will be our answer for question number 1. Let's go over to question number 2. It says that simplify root 2 plus 1 over root 3, all brackets, open bracket again, root 2 minus 1 root 3. From the question already you can see that this is the difference of two squares. So we have question number 2 as using difference of two squares, this will give us root 2 squared minus, you can see the sign, so it's a difference of two squares, 1 all over root 3 squared. Now this power will cancel out this square, so we have 2 minus, the square will affect 1 as 1 and we cancel out this root as 3. Then to solve this, we take the denominator, multiply by this minus this. So we have 3 times 2 as 6 minus 1 all over 3. We minus the numerator, we have 5 all over 3, which is the same thing as 1 whole number 2 all over 3. That's how we answer question 1. Let's go back to question 3. Question 3 says, if 1 plus root 2 all over 1 minus root 2 is expressed in the form of x plus y root 2, find the value of x and y. We have question 3, 1 plus root 2 all over 1 minus root 2, taking it to the form of x plus y root 2. So that means we will solve it and it has to look like this. Then we get our x and our y. To solve this, we have to rationalize, that is, get the conjugate of the denominator. So we have 1 plus root 2 all over 1 minus root 2 multiplied by the conjugate. The conjugate is 1 plus root 2. So we multiply. We have 1 times 1, 1 times root 2, plus root 2 times 1, we have root 2. Root 2 times root 2, we have root 4, which is 2. All over, the denominator is a difference of two squares. So we have 1 raised to the power 2 minus root 2 raised to the power 2. So we add the like terms. So we have 1 plus 2, we have 3. Root 2 plus root 2, we have 2 root 2. All over 1 square, which is 1, minus root 2 raised to the power 2. Root 2 raised to the power 2 will give us 2. 3 plus 2 root 2. All over 1 minus 2, which will give us minus 1. So we are taking it to this form, so we have to bring up the minus sign. So this will give us minus 3 plus 2 root 2. The reason we have a bracket sign here is that the minus will affect both elements of this expression. So we have minus 3, we have minus 2 root 2. So looking at our expression, we have x as minus 3 and y as minus 2. So with this, we'll be able to solve questions unsolved.